So the last video has to do with a really kind of an exception to exception. It has to deal with hydrogen. So hydrogen and a historical accident about naming. So hydrogen was thought by an English chemist to be diatomic. Okay, and in Greek, two bi means two in Greek. In Latin, di means two. So because John Dalton, this 18th century chemist, thought that hydrogen was diatomic, he called hydrogen bi. Okay? Just kind of like mercury is called quicksilver, he called hydrogen bi. Okay? So when we look at phosphate, PO4 3-, we said that was phosphate, and it's got a -3 charge because it's in the -3 column. Now, what happens if we add a hydrogen out front? By adding a hydrogen out front, it causes the charge to drop by 1. Now, how do we name this? Well, there's a common naming system. Because Dalton thought hydrogen was bi, the common naming system is called biphosphate. And since it's got a charge, I'd call it a biphosphate ion. Okay? Now, if I add another hydrogen to it, the charge will decrease by 1 more. Whoops, I'm sorry, I jumped the gun here. I forgot I wanted to say something. So this is the common way of naming it, biphosphate ion, okay? The scientific way of saying this is mono. Mono means 1 hydrogen, so monohydrogen means 1 hydrogen phosphate ion. Well, that's a pretty long word to write, monohydrogen phosphate ion. That's why everybody likes to go with the common naming biphosphate, okay? So you already kind of see what I'm going to do next. So if I add another hydrogen, like I said, the charge decreases by 1. There's only one possible way to name this, and that is dihydrogen phosphate ion, okay? So the di means that there's 2 hydrogens because di means 2 in Latin, and bi means 2 in Greek. I know this is kind of a historical accident, but that's just the way it goes. So if we had this one, we would call that carbonate ion. It's not bonded to anything. It's got a -2 charge, the carbonate ion. But if I put a hydrogen in front of it, the charge is going to decrease by 1. So then I would call it a bicarbonate ion. Okay? Bicarbonate ions, well actually, so let's now do an example of naming. So what if I had this? Oh boy. What if you had this? Well, you name the Na, that's sodium. HCO3 would be bicarbonate. Okay? It's not an ion because it's bonded to something. It's bonded to the sodium. So I've got sodium bicarbonate. That's also known as baking soda, sodium bicarbonate. If you had this, this would be sodium, and this would be biphosphate, sodium biphosphate. Okay? Going the other way, suppose you had this, lithium bisulfate. So lithium is Li, it's got a 1+ charge because it's in the 1+ column. Bisulfate, well normal sulfate is SO4 with a -2 charge. Well, if it's bisulfate, I would put a hydrogen out front, and I would decrease the charge by 1. So that would be lithium bisulfate. I would crisscross my charges, boop, boop, and then the final answer would be this. Okay? People always ask, when do I put parentheses? When in doubt, write the parentheses. Okay? You can't go wrong by putting parentheses. If the number outside the parentheses is a 1, you don't need the parentheses. You can just leave it like this. But if the number outside the parentheses is, let's say like this, aluminum, let's do aluminum, if you had like aluminum bisulfate, well then aluminum's got a +3 charge, bisulfate it's got this, so when I crisscross, a 1 would go there and a 3 would go there. If there is a number greater than 1 on the outside of the parenthesis, you must keep the parenthesis. You cannot get rid of them. But what I tell people is if you're not sure, just leave the parenthesis. Okay, it's not wrong if you leave the parentheses when you don't need them. But it is wrong if you don't have the parentheses when you do need them. Okay? So that is the last topic on polyatomics. Okay?